Hello students, in this video we are going to implement decoders. So in previous video we saw about the implementation of encoders using static CMOS logic. Now we are going to look into the decoders. So now what is a decoder? Decoder is a multi-input, multi-output logic circuit. Same encoders also, because whatever data we have encoded, we are going to decode. So whatever inputs are there will be at the output, and whatever the output is there will be in the input. So decoder is a multi-input, multi-output logic circuit which decodes n inputs to 2 power n possible output. Previously in your encoders, we had 2 power n input and n output. Now I am decoding that particular data. So n input will provide you 2 power n output, and E is the enable. So if your enable pin is 1, it is enabled, or else it is disabled. Right? Now we are going to see for 2:4 decoder as well as for 3:8 decoder. The same way we did for 4:2 encoding and 8:3 encoders. Now 2:4 decoder. So there are 2 inputs and 4 outputs. So what are the inputs? A1 and A0 be the inputs, and D0, D1, D2, D3 be your outputs. Right? What are the combinations that I can use with the two variables? 0, 0, 0, 1, 1, 0, 1, 1. So now 0 and 0, where your data will be? So towards D0. D0 is equal to 1. Remaining everything will be 0. Again 0, 1. What is the decimal equivalent corresponding to 0, 1? 1. So I have to write 1 towards D1. And now 1, 0. What is the decimal equivalent of 1, 0? 2. So I have to write 1 towards D2. And now 1, 1. What is 1, 1? It is 3 binary equivalent. So towards D3, I have to write 1. Now, look carefully what I have written. D0 is equal to, what is D0? It is equal to A1 bar, A0 bar, because both are 0 and 0. 0 is nothing but A0 bar, A1 bar, and D1. What is D1? Which is A1 bar into A0. What is D2? A1 into A0 bar. What is D3? A1 into A0. So now we have to implement these 4 expressions using any logic. In previous encoding, we saw about static. We saw there are so many transistors that has been used. Now here we shall try with pass transistor. Right? So now what is this transmission gate or pass transistor logic? Now see A, C and Y. What is this? If my control signal C is equal to 1, what is the output? Y is equal to A. If that C is 0, Y is equal to 0. So what is Y? Y is nothing but A into C. Right? Y is nothing but A into C. We learned in previous video for multiplexer. If you go through that particular video of multiplexer, you can understand what is this A into C means. Right? Just multiply A into C, you will be getting your output Y. Now, using this particular logic, we are going to implement D0, D1, D2, D3 using transmission gate. Now see, what is D0? A1 bar into A0 bar. So what has to be my control signal? A1 bar and A0 bar. See, A1 bar. See the first transmission gate. Just directly, you don't want to confuse much. Just A0 bar into A1 bar. That is going to give you D0. Right? 0 and 0. Next, what is this? Next one, D1. D1 is equal to A0 into A1 bar. So A0 is given as one input, and one more control signal I am giving us A1 bar. See, it is a transmission gate. So on to the opposite, we will be having a PMOSFET that will be having, if A1 bar is given here, it will be A1. And now what is D2? D2 is given as A0 bar into A1. So it is A0 bar into A1. What will be on the bottom for the transmission gate PMOSFET, which will be A1 bar. Again, what is D3? D3 is equal to A0 into A1. So I have given one input as A0 and one more input as A. 1. So I will be getting D3 is equal to A0 into A1. Right? This is all about my 2:4 decoder. This is all about my 2:4 decoder using transmission gate. It is so simple. I've just used A0 bar and A1 bar be the input and 1 be the control signal. I've directly taken my output D0. Right? When D0 is equal to get D0, it is A0 bar into A1 bar. In the same way, it proceeds with D1, D2, D3 as well. Now, we shall see for a 3:8 decoder. What is this 3:8 decoder? A2, A1, A0 be the inputs. D0, D1, D2, D3, D4, D5, D6, D7 be the outputs. What are the combinations I can write? 0, 0, 0, 0, 0, 1, and it goes on up to 1, 1, 1. We know the various combination for 3 inputs. And then when the data will be 1, corresponding decimal equivalent you have to find for the inputs. And towards that particular subscript, you will be writing 1 that you all know. I'm just repeating it again to brush up the particular data. Right? Now, what we have to write? We have to write the Boolean expression. What is the Boolean expression? D0. D0 is equal to A2 bar, A1 bar into A0 bar. What is? Because all are zeros. Zeros are nothing but negation. So D0 is equal to A2 bar into A1 bar into A0 bar. And now, what is D1? D1 is equal to A2 bar, A1 bar into A0. What is D2? A2 bar, A1 into A0 bar. What is D3? The same way, A2 bar, A1 into A0. What is D4? A2, A1 bar, A0 bar. What is D5? A2, A1 bar, A0. What is D6? A2, A1, A0 bar. What is D7? A2, A1 and A0. Why I have drawn the dotted lines? See the dotted line? For D0 to D3, I have written separately. And for D4 and D7, I have separately. You just see the last that boxes, dotted boxes, all are common. What is this? A1 bar, A0 bar. Here for D4, it is A1 bar, A0 bar. Again, it is for D1, A1 bar, A0. Again here, A1 bar, A0. And here for D2, it is A1, A0 bar. And for D6, again, it is A1 and A0 bar. And for D3, it is A1, A0. And again, D7, it is A1, A0. There is some common thing. We shall use a particular common thing for implementing your 3:8 decoder using transmission gate. Don't panic on seeing the big diagram. It's dead easy actually. See what is it? 3:8 decoder. What is D0 value? D0 is equal to A2 bar, A1 bar into A0 bar. So what data is common? For D0 and D4, A1 bar and A0 bar are common. So see here, I have used A0 bar as a control signal as one of my input and A1 bar as the control signal. So A0 bar and A1 bar has been generated. Now what has to be added again to generate D0? A2 bar has to be added. So A0 bar, A1 bar and A2 bar. That will give you D0. Next, what I have to generate? I will be generating D1. But what is D4? D4 is equal to A2, A1 bar, A0 bar. We already have in our hand what is the value? A1 bar and A0 bar. So A1 bar into A0 bar, when it is multiplied and it is given with A2, we will get D4. Where is A2 available? As it is a transmission gate, previously we have given A2 bar in the NMOS. So for PMOS, the control signal will be A2. So I can directly use that particular A2 and give it to my NMOSFET and I will get D4, which is A0 bar, A1 bar and A2. Again, next, what we are going to find? D1. What is D1? A2 bar, A1 bar and A0. So A0, A1 bar, that has to be multiplied again with A2 bar. We already have the expression A2 bar. So we can directly connect that line to my NMOS. my output will be D1. With A0 and A1 bar, I can also generate D5 if I multiply it with A2. So multiply it with A2, I will get that particular value in your output. And next, what is D2? D2 is nothing but your A0 bar and A1 bar, A0 bar and A1 multiplied with A2 bar. So you can easily generate if you put a direct connection by using two transmission gate. With A0 bar and A1, what I can get? I can also get D6 if I multiply it with A2. So A2 is already available. So I can directly connect from P MOSFET to N MOSFET A2 and I will get D6. Right? Still now it is okay. Now next is, it's okay, right? So now next is D3. So for D3, we want to get that expression which is A2 bar A1 into A0. What is A0 and A1 are given as the input and control signal. We have generated A0 and A1. And with the A0 and A1, I'm again multiplying with A2 bar. A2 bar is already available in the P MOSFET. So I'm directly connecting that A2 bar line to my N MOSFET and I am taking D3. With A0 and A1, again I can generate D7 if I multiply it with A2. So I have A2 in my P MOSFET control line. So with this A2, I connect directly to my N MOSFET and I will get my D7 expression. Right? So for a 3:8 decoder using transmission gate is so simple, though it looks little bit confusing. It's not confused one. It is so easy. Just multiply 3 datas. Take an output. Simple. A0 bar, A1 bar, A2 bar. A0 bar, A1 bar, A2. So if you move on like that, you can generate D0, D1, D2, D3, D4, D5, D6, D7. So in next video, we shall see about latches. Thank you.